Hello, friends, in today's video we will find out what pi is and see the proof of the area of the circle equal pi r squared. I hope you are enjoying this calculus series. Don't forget to subscribe to our channel. Here, we have 10 centimeters of wire. I changed it to a circular form. So this yellow colored curve of the circle is called the circumference of the circle. What is the circumference? The perimeter of the circle. So, in this way, the circumference of this circle is 10 centimeters. Secondly, we refer to the distance between one end of the circle and the other end as diameter. And when we make a circle of 10 centimeters wire, then we will get to see the diameter of 3.183 centimeters. Now we find the ratio of the circumference and diameter of the circle. When we divide 10 centimeters by 3.183 centimeters, then we will get approximately 3.141 value. Now let's take a wire of another length and make a circle out of it. The second wire is 7 centimeters. We changed this wire into the shape of a circle. Then we got its diameter as 2.228 centimeters. Let us now look at the ratio of both its circumference and diameter. Dividing 7 centimeters by 2.228 centimeters, we again get the same value of 3.141. All circles are similar geometric figures. They all have the same shape up and differ only in size, which means diameter. The ratio of circumference to diameter has the same value for all circles. The number pi is defined to be this common ratio. We know that the diameter is twice the radius, so we can say d equals to r. On rearranging, we got the formula of the circumference of the circle. The circumference of the circle is equal to 2 pi r.
I got it.
In school, we are taught that the area of a circle is the same number pi times the square of the radius. How can we deduce this formula? The answer to this question lies in regarding the circle as a limit of regular polygons, which are in turn made up of triangles, figures about which we know a great deal. Suppose we have a circle whose circumference is c and area is a. And a regular polygon having 5 sides is inscribed in this circle. P5 is the perimeter of this regular polygon and A5 is the area. Look at this carefully, and we will know that its area is less than the area of the circle because regular polygons have not yet covered the area of this circle completely, which means its area is less than the area of the circle. The perimeter of this polygon is less than the circumference of the circle. Here, this regular polygon had 5 sides. Now we increase the number of sides. A regular polygon having 7 sides is inscribed in this circle. We can see that the polygon has covered the area of the circle a little more than before. But its area is still less than the area of the circle. And the perimeter is also less than the circumference of the circle. Let us now inscribe the regular polygon of the 9 sides in this circle. It is seen that this time the polygon has covered the area of the circle better than the first 2. But still, its area is less than the area of the circle. And in the same way, its perimeter is still less than the circumference of the circle. Let's try another regular polygon that has 11 sides. So now you can see that the sides of regular polygons are increasing in number, they overlap more and more. What happens when regular polygons have too many sides? Then it will start to look like regular polygons exactly like circles. Or we can say that it will completely overlap that circle. Then the area of this regular polygon will be approximately equal to the area of the circle. And its perimeter will also be approximately equal to its circumference. So finally, when the number of sides of the polygon kept on increasing and started approaching infinity, then the perimeter Pn of the regular polygon approaches the limit of circumference C of the circle. And the area An of the regular polygon approaches the area of the circle. So if we get the area of this regular polygon, then we will also get the area of the circle. Now what will be our next step is that we will find the area of this regular polygon when the number of sides approaches infinity. Before proceeding further, one important thing for you, please subscribe to our channel so that you can get notifications of upcoming videos. For our convenience, I have used a regular polygon of finite sides, so that we can easily analyze it. Look at this triangle OAB. Many such triangles will be formed in this polygon. Since the total angle around the point O is 2 pi radians, the angle AOB is 2 pi upon n radians. If M is the midpoint of AB, then OM bisects angle AOB. So it's pi upon n. From here, we can see that we can write the length of AB as 2 times of AM. Now let me show the triangle OAM separately from these. This is a right angle triangle. Sin pi upon n will be perpendicular upon hypotenuse. Which is perpendicular? AM length. And what is the hypotenuse? R. So sin pi upon n equals length AM upon R. On rearranging this, we got the length of AM. So the length of AB is now equal to 2R sin pi upon n. Now we have got the length of one side of the polygon. If there are n number of sides, then the total length of the polygon will be n times AB. And we write it by rearranging it. So in this way, we get the perimeter of this polygon. Let us now find the area of this polygon. Before that, in this triangle OAM, we will use the formula of cosine. And from here we will get ohm length. First, we find the area of this triangle OAB. The formula for the area of the triangle is half into base into height. We know both length AB and OM. So in this way, we got the area of this triangle. We know there is n number of triangles in this whole polygon. So what will be the total area of a polygon? N times the area of the triangle. What we have done so far is that we first find the perimeter of this polygon, then its area. Now we have two formulas, one for the perimeter and the other for the area. I have rearranged the formula for the area a little more. Now you must have been clear that we can input Pn in it. What do we have to do to convert this polygon into a circle? To do this, we will increase the number of its sides. Means n approaches infinity. Pn perimeter of the polygon will be equal to the circumference of the circle. Now, in place of Pn, we will put 2 pi r. Secondly, if n is approaching infinity, then pi upon n will approach 0. This means the cosine of pi upon n will be 1. What did we finally get? Area of the circle equals pi r squared.